Hi, in this video we're going to talk about some equilibrium relationships and then also talk about reaction quotient Q. So our first relationship is the relationship between K and concentration. And then when concentration doubles, K gets squared. Concentration triples, K gets cubed. And when concentration decreases by 1/2, it is the square root of K. And now the same holds true for Kp and other Kq values. And this, when concentration doubles, it has to be every single species of the reaction. Every single element of the reaction have to double together in order for the K to get squared and etc. Now our second relationship is reciprocal. And that is when A plus 2B forms equilibrium C and K equals 8.0. You can find K by using, you can use this equation, 8.0 equals concentration of C over concentration of A times B squared. But when you reverse it, because they form equilibrium, you can have a forward and reverse reaction. When you reverse it, K will equal to 1 over 8.0, which is equal to 0.13. And this will be 1 over 8.0, and the reactant product will swap as well. Now finally, combining equations. Adding a series of reactions requires that the equilibrium constants of each elementary step to be multiplied. So if A plus 0.5B makes D, and D plus 0.5B makes C, then A plus B will equal to C, right? Because the D cancels out, A plus B equals C. If the Kc for this one is 7.0, and the Kc for this one is 6.0, then this reaction will have a Kc of these two multiplied, which will be a Kc of 42. Now finally, let's talk about the reaction quotient Q. Reaction quotient Q. Now Q, just like Keq, equilibrium constant, is equal to product to their mole power divided by reactants to their moles power. And now this is used to compare concentration of products to reactants at a given time, and which determines if a reaction is at equilibrium. If Q is equal to Keq, then that means the system is equilibrium. If Q is greater than Keq, that means more product than when at equilibrium. And the reaction proceeds to the left. Basically, the reaction will shift to the left to increase reactants. Now, if Q is less than Keq, that means more reactants than when it's equilibrium. And then the reaction will proceed to the right side. The reaction will shift to the right side, which increases the concentration of products. And that is it for this video. Thank you for watching.